Hey guys, let's look at the chapter 6 homework. So this is our first question here. Suppose you were to collect data for each pair of variables listed below. You want to make a scatter plot. Which variable would you use as the explanatory and which is the response? Why? Okay. So cell phone data plans for a person who wants a large file size, the file size and the cost. So our explanatory, so probably our file size would be used to predict the cost, because file size could be used to predict costs. All right, now probably it would be, as the file size gets bigger, the cost would be more, so that's a positive association. It's probably fairly strong. Lightning strikes by a person watching a lightning storm, the distance from the lightning and the delay of the thunder. So the distance would tell us what the time delay is, right? So because distance could be used to predict the time delay. Wait. It should be the other way around. It should be our time delay would predict the distance, because the time delay could be used, right? Because that's what we normally do. Like when we're listening to a storm, right? We count the seconds and then we predict how far away the distance is. So it would be negative, right? No, I'm sorry, positive, because the longer the time delay is, the bigger the distance would be, right? And it would be very strong. A street light you are approaching, its apparent brightness and your distance from it. So the apparent brightness could predict the distance. This would probably be a positive, no, a negative association, because as you get brighter, the distance would get smaller. But it probably would be, let's say strong. Okay. And cars being cataloged at a dealership, the weight of the car and the age of the owner. The explanatory variable could be the weight of the car, and the response variable could be the age of the owner, because either variable could be used to predict the others. Then we would have no direction and a weak correlation when that's the case. Which of the scatter plots to the right shows no association? That would be 3. A negative association, that would be 1, because it's going down. A linear association, that would be 1, because that looks most like a line. A weak or moderately strong association. Well, let's just go in order. So no association, that would be 3. Well, actually 3 is more like a weak association. So I'm going to say none of these scatter plots show no association, because I'd expect it to be all over the place for no association. This is very weak though. So which is a negative association 1, because it's going down and to the right. Which shows a linear 1, because, okay, 1 and 3, because you can kind of see a line through it. So this is much weaker, but this shows a straighter line. A weak or moderately strong association. Well, that's a moderately strong association. That's a weak association. This would show a fairly strong association, but it would be nonlinear. So they may be looking for all of these scatter plots. Nope. Okay, so then just 1 and 3. Well, okay, this is a weak one. They included weak in there, so that's what's throwing me off. So I guess they want 1 and 2, because 1 is a strong association, 2 is a nonlinear association. They wanted only B, 2 and 3. Oh, because they wanted this one classified as very strong since it was close to a line. I was including that in the moderately strong category. They want it to be very strong since it's straight in a line. Okay, that makes sense. I should have read further along and saw that that was the next question, E. So that's just number 1. A study examined brain size measured as pixels counted in digitized magnetic resonance image of a cross-section of the brain, and IQ for college students. The scatter plot to the right shows the performance IQ versus the brain size. Describe the association between brain size and IQ. All right, so this is our picture. It doesn't look like there is any correlation here, right? Because I can't see a line through here. So I would say very weak or possibly no association between the variables. If we assume that the conditions for correlation are met, which of the following are true? A correlation of negative 0.98 indicates a strong negative association. That's true. By the way, it's strong because it's close to -1. Multiplying every value of x by 2 will double the correlation. That's false. It will not change the correlation. The units of the correlation are the same as the units of y. Correlation has no units. Okay. If we assume that the conditions for correlation are met, which of the following are true? A correlation of 0.02 indicates a strong positive correlation. That's false because 0.02 is close to 0. Standardizing the variables will make the correlation 0. And that's false. Right? Standardizing the variable shouldn't change the value of the correlation. Adding an outlier can dramatically change the correlation. That is true. Okay, so A we said is false. So because there may be no correlation between them. B. And then this statement's true. Adding an outlier can dramatically change the correlation. Here are several scatter plots. The calculated correlations are here. Which is which? Okay, so negative 0.977 is a very strong negative. So that's C. 0.777 is a pretty strong positive. That's the closest to a line looking one, so that would be D. All right, see how this is a little bit negative? So we're going to go with the negative 0.487. That's A. And then 0.006 is our expectation here because this is a nonlinear correlation. Consider the accompanying data from 23 randomly selected students. The data were reported by students to a consensus website. Find the correlation coefficient for the given data. All right, so we got arm span and height. All right, I'm going to show you how to do this on your calculator because that's probably what you're used to using. But we could just do this right here in Excel. And in fact, it's really, really easy to do it right here in Excel. If I just highlight these two, actually, I don't think I need to highlight either. I just go over to the data tab and do my data analysis and do my regression there. Yeah, so my input would be height. And other input would be arm span, like that. And then give it an output place here. And that's good. And it gives you your regression right here. So that's a really fast way to do it, but I'm going to show you how to do it on your calculator. So we're going to put in the data, 164. And actually, I tell you what, I'm going to pause this recording while I put in the data so you can pause here and then unpause once you've entered all the data. Okay. All I did is put this data into list 1 and list 2. So my list 1 is my height and my list 2 is my arm span. Now let's go back to the question. I want the R. Okay. So I told you that when you're doing this, you need to first turn on your diagnostics. So if you haven't already done that, hit 2nd and 0 to bring up the catalog and scroll down to where you see the diagnostics. So you've got to get all the way to the D's and go to where it says diagnostic on. There you go, right there, diagnostic on. Hit enter and it'll say done. Okay, so you need to do that part first. Then go to stat, calc, and we want to do the linear regression option 4. So I want my X list to be list 1, and then my Y list to be list 2, and calculate. And my R is 0.6148, so it's 0.615. By the way, right there, 0.615. Next part. Because the scatter plot is linear, it is, by the way, I know it's linear because this is closer to 1 than it is to 0, right? It is, oh, sorry, let's look at the scatter plot. Second stat plot. Turn that on, go over here to the scatter plot, and then zoom option 9's a stat to fit it. And see, that looks kind of, you know, going up and to the right like that, sort of linear. It is appropriate to calculate the correlation. The value for the correlation is positive, which confirms the positive trend. The value of the correlation coefficient R equals 0.615. Confirms that the data are reasonably associated. Here are advertised horsepower ratings and expected gas mileage for several 2002 vehicles. Make a scatter plot for the data. Okay, so let's go over here. We're going to go into stat, edit. Let's clear out the lists that are in here from that last problem. All right, let's put our horsepower in. And then let's put in our gas mileage. All right, now go into the stat plot. It's on the scatter plot. So just zoom 9 and it looks like this. So let's find the one that looks closest to that, and that would be that one. So this is a negative straight, very strong association. And let's find our R. So we're going to go to stat calc 4. Enter, enter, enter. And it's 0.965. Whoa, what did we do? Negative. Oops, I forgot the negative sign. That's a big oopsie. What does the plot say about fuel economy? The vehicles in the selected group with more horsepower have lower mileage because it varies inversely. So I should choose option B. Fast food is often considered unhealthy because much of it is high in both fat and sodium. Are the two related? Here are the fat and sodium contents of several brands of burger. Analyze the association between fat content and sodium using a scatter plot. All right, so let's put our fats here. And our calories, or sodium, sorry. Okay. And zoom 9, because we've already got the scatter plot on, looks something like that. That looks like this one, maybe. Yep. And our correlation coefficients, stat, calc, 4, enter, 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 enter. 0.192. So we want to know how is it associated? Now, notice that 0.19 is very weak, right? So we would say there's no apparent association. Look at that scatter plot. I mean, it seems to go up a little bit as the fat content goes up, sodium goes up a little bit. So this is a extraordinarily weak, right? But it's not really curved. So let's go with that one. In a scatter plot, we try to describe the direction of an association. The positive direction is one that can be described out from the lower left to the upper right. Which of the following best describes a response variable? Dependent. We hope to predict or explain. Might change in response, so all of the above. Explanatory variable is the independent, so A is wrong. It explains or predicts changes in the response variable, but it does not cause changes. What is the correlation? Measures the strength and direction of linear relationships. We should always calculate the correlation between two variables. No, we should only find correlation between two variables if they are quantitative, the association is straight enough, and there are no outliers. That's true. That's true. That's true. That's true. All right, guys, that's your chapter 6 homework.